Greetings, gentlemen and ladies. Morning, good afternoon, good evening, wherever you may be. Today, we begin a series of discussions on epithelial tissue. Quickly, we go into classification of epithelia, and this classification will give a guide on the criteria that we use for classifying epithelia. First of all, we look at the number of layers of the covering cells that is making up epithelium. So if it is just one layer of cells, then that epithelia will be considered simple epithelium. If the cells are more than two or more in terms of layers, then we say they are stratas, layers, they are stratas. So we say this type of epithelium is stratified. Then we can have one layer of cells, but these cells, some of them will be shorter while others will be taller. So when you look at the histological appearance of such a tissue, you will see that maybe there are several layers of cells. No, but it's just one layer of cells, except some of them are taller than the others. So they tend to look like there are several layers. So this type of epithelium is called pseudostratified, a fake stratification or a fake layered kind of epithelium. Then we also classify epithelium based on the shape of the cells that make up epithelium. So these cells could be flat, and so they are considered squashed or paved, and so that type of epithelium is called squamous epithelium. If the shape of the cells that make up this epithelia are cube, square-like, they are considered cuboidal. So this epithelium will be called cuboidal epithelium. But if the cells that make up the epithelial tissue, they are tall cells, then this epithelium is considered columnar epithelium. Then we also use the presence of cilia to classify epithelium. That cilia, these are finger-like projections on the surface of cells. So these, they beat in one direction, mostly to clear secretions on the surface of these cells. So if the epithelium has got cilia, we say this is ciliated epithelium. But if it is not ciliated, we don't emphasize whether it is unciliated. We just go silent. But if it is ciliated, then we'll say it is ciliated epithelium. Then there is also another issue where some epithelia have got keratin protein on the surface of the cells. So that type of epithelium, which gives the strength, the resilience of that type of epithelium, like the skin, we consider that type of epithelium keratinized. Okay, so now you notice that we will be using a combination of these characteristics to give the name to a particular type of epithelium. So we will look at the type of epithelium, and then we ask ourselves, how many layers of cells are there? What's the shape of the cells? Is it ciliated or not? Does it have keratin or not? And so then we'll end up with a simple squamous, pseudostratified columnar. We'll end up with stratified squamous, stratified cuboidal, keratinized, ciliated, pseudostratified, and things like that. So let's move quickly. This is just a reminder on the major tissues that we consider. So we are looking at epithelia. We've already considered nerve tissue, and we'll be moving to muscle, then finally connective. So epithelia, the function is basically for protection of body surfaces and organs, but also to perform the functions within which those covering surfaces the tissue that is being covered is performing. So there is secretion of, for example, the digestive system, glands, absorption, as well as the excretory activity. For example, the skin, through sweat we excrete a lot of substances. So epithelia will be found in so many areas of the body, mostly covering body surfaces and the organs as well. The distinguishing characteristics we'll discuss, and you'll find that there are issues of poor perfusion, poor blood vessels, and also the tightly packaging of cells that make up epithelia. So let's begin with the general characteristics, and what we are discovering about general characteristics, that epithelial tissue is widely spread throughout the body, covering body surfaces and lining internal organs. Then epithelia are anchored on the basement membrane. So there is a membrane of connective tissue on which the epithelial tissue anchors. And the cells that make up epithelial tissue, they are tightly packed, meaning there is close apposition. There is close apposition of cells. And blood circulation, the blood vessels are mostly lacking in epithelial tissue. Therefore, the materials needed by the cells to survive for epithelial tissue, they tend to diffuse. And this epithelial tissue is frequently replaced. Let's start with simple squamous epithelium. So simple means one layer, squamous means these cells are very flat. And so simple squamous epithelium is made up of a single layer of thin, flattened cells. And because these are very thin and it's just one layer, these surfaces which are covered by simple squamous epithelium are very, very important for areas where there is exchange of materials. So we are talking about the lymph vessels, we are talking about the alveoli in the lungs, we are talking about capillaries where nutrients and gases are exchanged. So this is an illustration of the same. You can see the paved cells, flat cells that make up simple squamous epithelium. Simple cuboidal, again, that means simple means one layer of cells. Cuboidal means these are cube kind of cells, not flat but cubes. So this, obviously, where do we find them? We find them in secretory sections of the body. So they function in secretion and absorption. For example, in the kidneys, they make up the tubules of the nephrons, and in the secretory sections of the glands. So you can see those are the glands with their lining of simple cuboidal epithelia. Simple columnar, simple means one layer, columnar means toe cells. So simple, one layer of toe cells. And where do we find these? We find these lying in the uterus, for example, in the stomach, intestines. What's their function? To protect the underlying tissues. And also in the secretory function for digestive fluids and the absorption of nutrients. In the intestines, these cells possess villi, which are finger-like projections, and these they increase the absorptive capacity of the intestines. So mucus secreting goblet cells also in the stomach are very, very important, where they perform the function of secretion of mucus. So again, you can see the toe cells there with just one layer. So simple columnar. We go to the pseudostratified columnar. Remember, we said pseudostratified means that it's a fake, it's a copy of stratification. It's just one layer of cells, except some of them are taller than the other. So the appearance histologically exhibits that there are two layers of cells instead of, there are several layers instead of one. So these cells appear layered due to the varying positions of their nuclei within the row of cells, but are not truly what? Layered. So cilia may be present, therefore they will be called ciliated pseudostratified columnar, and you find this, for example, in the trachea or the upper respiratory system. So this is what we are talking about. You can see the goblet cells there. You can see the toe cells with cilia on top. Stratified squamous. So we've moved from one layer, now we are looking at least 2 layers of cells. Stratified means there are several layers. Stratas as in layers, okay? Squamous means the cells are flat. So where do we find several layers of flat cells? We find in the skin, we find the lips, we find in the vagina, we find in several areas. So this type of tissue is made up of layers of flattened cells that are designed to protect underlying layers. So it makes up the outer layer of the skin, the mouth, the throat, the vagina, the anal canal. In the skin, the outer layers of cells are also keratinized. So we find that the skin, it is not only stratified squamous, it is also what? Keratinized stratified squamous. But in the vagina, the epithelium is not stiff to allow the physiological function of the vagina and also to allow for copulation or sex, what you call sex, copulation. So to avoid injury, the epithelium functions in a way where there is no keratin. So the vagina is one place where you find non-keratinized stratified squamous epithelium. I'm sure for the gentlemen, you won't have to forget that. So this process does not occur where tissues remain moist in the throat, the vagina, and the anal canal. So this is what we are talking about. You can see flat cells, but so many layers of them. Okay? Stratified cuboidal, so several layers of cubes of cells. You find these in the mammary glands or the breast. You find in the sweat glands, you find in salivary glands, and the pancreas. So several layers of cells provide greater protection than one single layer. That is a very important message. So this is what you are seeing. Several layers of what? Cuboidal cells. Stratified columnar. This tissue consists of several layers of cells and is found in the vas deferens. This is in the testis, part of the male urethra, and also in parts of the pharynx. Okay. Transitional epithelium. What is meant by transition is like this epithelium, you look at it under the microscope now, you think it is very thick, several layers. But if you look at it at another time, you think it is very thin. This kind of changes in the way it appears is what is called transitional. And it's because such organs that are lined by such epithelium are able to stretch. So transitional epithelium is designed to distend and return to its normal size, as it does in the lining of the urinary bladder. So this design is aimed to provide the ability to stretch or distensibility and keeps urine from diffusing back into the internal cavity, because this allows now more urine to be accommodated. So this is what we are talking about.